Alright, so now we know kind of what we're doing here. You know, I'm kind of winging around the tape measure. It's time to actually start some work. So what we're first going to do is make that cross member to attach to the hitch right there. So first we need to know how wide, good lord, this tape measure just, how wide the mounting brackets are on the 3-point, which are 26 inches. For the sake of extra room, I think I'm going to make them 30. So through the magic of YouTube, as you can probably tell, I was already doing some mathemagicals. I got that all set up here. So what I did, mainly because I don't trust myself to be that accurate with that saw, and that thing is way too awkward and way too heavy to maneuver into that little corner shop. Yeah, that's what that is. Oh, and never mind the weed patch there. I kind of need to, yeah, we ain't gonna worry about that today. Anyway, what I did is I decided to measure off 34 inches of this piece of steel. Believe this is, what is this? I want to say it's 1/2 inch. I picked up a piece of 1/2 inch stock. I don't even remember. It's been laying here a couple days. Not quite 1/2 inch. What the heck is it? 3/8. Some 3/8 square tubing, 6 by 3 by 3/8. And we're going to attempt to lop off a small piece of that with this Milwaukee. Now these are, for those of you that are not familiar with these, they are cold saws made for cutting 1/4 inch steel. So yeah, it should handle it just fine. All right, let's see what we can do. Say for cutting something that it was not intended to, we did all right. Now, in case you're wondering why I didn't use that torch, well, you know, hindsight's always 20/20, but I'm out of oxygen already. So, thoughtful planning on my part. But look at that cut. I mean, come on. That, if that just doesn't say Milwaukee, I don't know what does. Now comes the real fun part, and that's gonna be, you know, lining that up with the other side. But, you know, this side probably won't be the problem. It's gonna be a, actually stayed on my mark somehow. All right, back to it. Now the one thing I've never liked about this saw, only thing, is that foot plate. But always vibrates loose, but yeah, whatever. And in no bind. Yep. All right. There's my review on the Milwaukee 8-inch metal saw. Milwaukee, you can send that check, you know, in the mail. That'd be awesome. Maybe just give me a lifetime discount on tools. That would also be awesome. In all seriousness, do yourself a favor. Go buy one of those. I mean, come on. And a little tab there. We'll take care of that on the bandsaw in here. But when that's used for what it's intended, it's actually a pretty awesome little unit. All right. I don't know about you. Just making sure that the old camera is still working, so no. Right. Kind of got to plug. Kind of got to have power. But anyway. Now I know what you're thinking. Somehow know it. You're asking, how do you know that's the right length? Well, I don't. Kind of roughing it at this point. Just wanting to get it somewhat square. Yep. Not bad. Not bad for eyeing it up. About an inch. So we're going to square up this side. And we'll go ahead and square up the other side. Well, I thought well, looks like we're gonna have some problems. So, cool. Be right back. All right, let's get this squared up here. Whoa! We don't need that much. We might. Definitely doesn't like this thick stuff. That's alright. Alright, so I'm gonna get this squared up and then I'll come back here and let you in on the next step that we're gonna do. before it goes on the air cart. Alright, so we got our piece of steel now chucked up here in the mill. I got this set up for some face milling. I'm sure you machinists out there are looking at that just screaming, saying improper use of a tool. Probably is. Here's what I'm gonna do with it. So this thing is exactly 3 inches thick, and usually I say in all of John Deere's infinite wisdom, but in this case I can't, in all of Flex Coil's infinite wisdom, probably because, you know, Canadian made metric system, I don't know. The hitch gap on this unit is just shy of 3 inches. We're looking at 2 and 7/8. Am I saying that right? 2 and 7/8. Actually, more like 15/16. 2 and 15/16. And that's where that thing's got to go. So I got to shave off. Honestly, I'm probably going to shave off an inch. Or inch. Oh my goodness, you can tell. It's been a long day, guys. Long day, not even tax season. I gotta shave off 1/8 of an inch off of the face of this piece of steel. Now, I could do the whole thing, right? Could do that. That'd be too easy. So what I'm going to do is shave off just enough for that hitch. So, just kind of get that hose out of the way. We don't want to do too much here, but yeah, about, you know what, we'll do 8 inches. I'm pretty sure that's a 2 inch. Isn't that 2 inches? Might be an inch. I think that's an inch. That's 2 inch. Anyway, gotta do 8. So now we gotta do some thinking, some mathematicals. So we know this is about 30 inches. Ooh, somebody didn't measure right. What the heck? Anyway, we're gonna say it's about 30. It's just what we're gonna do. So to do this right, I need to come in off of each end. So from dead center to the end is 15. So off of each end to that is 15. Back out 4, that'd be 11. So I need to come off about 11. Put in the dot. Come off the other end, also by 11. Put in the dot. Holy moly, this is looking pretty big. I'm not liking this. This is going to be fun. I really am not liking this. This just does not look fun. And there's a lot of shadows. I'm probably gonna call it a day here shortly. All right. So that zone is what I need to mill down. That'll be fun. Probably not. so made a few more passes on that same depth, and honestly, for probably improper use of a tool and for a cheap tool off Amazon, I'll take that. You see these little ridges that are in there? If you ran your finger over it, you could feel them. I think I'm going to attribute that to excess heat, where that tool is expanding a little bit and causing it to cut a little deeper. You would hear that as I was backing out, going back over some of these earlier passes. You'd hear a little bit of chatter in the blade, or rather the cutter, not the blade, but I digress. That's what I'm thinking that is as this piece heats up, which, yeah, you can feel there's some heat in that. That's what caused that. So if you were doing high precision something or another, like machine work for an engine or something of that nature, yeah, you'd want to go back over that with a finishing pass. But for all we're doing, we just wanted to remove material so that it'll fit into that slot over there. So let's see how well we did. We can get it out of there. There we go. There we go. Make a couple weld passes around that and call it a day. Now we just got to put the uprights on there on each side. Gotta get these stupid things out of the way. I don't think well, maybe I have mentioned how much I hate those tubes. They're ultra flexible in the summer, but man, in the fall when you want to use this thing, not the greatest of friends to have. Yeah, I think that'll fit our needs nicely. So, all right, I'm gonna go get the pieces cut for our uprights, and then I'll take you through drilling the holes for that, and doing a little bit more milling and machining on that as well. So okay, so I got my 3-foot pieces cut. There's one all chucked up, not chucked up, but clamped up in the milling machine, and the other one just off to the side. And so now what we're going to do is we're going to turn these blank pieces of steel into something that looks like this. So here's our 6-foot wide piece. We're going to go 12 inches up and then come over 1.4375, drill a hole, go over another 4.5625 inches, drill another, so on and so forth. To get this to come out right, I'm going to use our digital readout. So first we need to come up with a reference point. So basically that little corner piece is what I need to come up with. So to do that, I need to first set the 0 as it's reading right now, as if it were right here, basically centered over that little lip. So I'll show you how I do that here, and then we'll get started drilling our pilot holes. I am using all I got memorized is the numeric. I don't have the fractional, but it's 0.234 is the size this is. I know it's the size just below a 1/4 inch, obviously, but at any rate, that's what we're going to drill our pilot holes with. It's stout enough to do that in this heavy steel, and it's also the same size as the pilot bit on our hole saw. I guess you call it a hole saw. I'm not sure what you really want to call it, but this, which is our inch hole that we will pop into this piece of steel that our bolts will ultimately go through, that'll bolt that 3-point hitch onto the air cart. So, enough talk. Let's see this in action. Okay, so as I said, I got this clamped up. Yeah, technically not the right way to do it. Yeah, you should have a machinist jack down here holding up this end, but again, we're not really going for absolute precision, just going for good enough precision. So at any rate, what we're gonna do is we're gonna find the center of this edge line. So what we'll do, we'll run our piece of steel right up to just when it taps that bit. Okay, then we will zero out our x-axis. So now that's zeroed. Now I will raise the bit up. I'm going to move this over, not 2, 3, 4, but half of 2, 3, 4, which is what? Heck, I don't even know. I should know this. I'm an accountant. I should be able to do math. But I use an adding machine. 117, so we're going to move this over 117. So we'll just kind of get this thing going here. Kind of went the wrong way. We're 1, 1, 1. Good enough for me. Oh, for crying out loud. There's this thing called close enough is good enough. Now we'll drop that bit down. And what do you notice? I don't know if that GoPro can get in that close, but right there where the tip of that bit is right there on the edge line. So, boom. That is our new zero mark for the x-axis. Come on, there you go. All right, so now we got our X set up good. We will continue to bring that back, because when someone unloaded that air compressor, that someone being me, kind of sat it a little too close to the milling machine. Anyway, all right. So now we need to do the same thing to this line. And as I said earlier, the whole reason I was bringing that this way is so I can clear that tank. Again, I know, amateur mistake. Laugh at me, I really don't care. Now, notice something else. We have a radius end, or radius side, or whatever the heck you want to call it. That's fine, because there's also another step to this that you don't see. Where the heads of the bolts are going to be, we're going to do a similar process, kind of like what we did on that cross member over there, where we took that facing mill and went across, just to get everything so that it sandwiches together nice and neat. So anyway, enough chit chat there. Now I know there's a proper tool for this. They call them edge finders. But unlike a fully tooled machine shop, I do not have that. So what I do is I'm just using that. All right, now this is our y-axis. Zero that out, pull that up. Now we're gonna 117. Go into that 117. There's 114, 116, and we went a little too far. This axis is a little sticky. There we go. 117. Now if we pull that down, why, look at that. It'd be right on that edge line. I don't know if you can see that or not, but I'm gonna say good enough. Select my y-axis, hit 0. Okay. So now we need to go over 1.4375. Okay. Now what I did earlier is I measured all of this out on that that 3-point hitch as to, okay, what is each side, what is it spaced at? And there's actually two different hole settings here that I determined basically by measuring, okay, I know that that's how high that is off the ground when it's fully raised, because it's in the fully raised position. I compared it to one of the tractors over there. The shop door just randomly shut. Got a ghost in the shop, I guess. At any rate, compared it to one of the tractors, and where that ended up being, that's where I am going to drill the first set of holes. The second set of holes up here, I just basically moved everything up 6 inches. So that way we get two, I guess, options if down the road, I don't know, if down the road that first set of holes doesn't suit our needs like it should, we're not totally shooting ourselves in the foot. Because that thing can go lower. It's getting it higher to transport is where your problems, from what I found anyway over the years, that always seems to be the issue. So with that, let's go fire up the welder to power this thing, and then we'll start punching some holes. One hole drilled. What I end up and did, that drill bit I had in there had a slight bend to it. So I swapped it out for just the hole saw, and we're just gonna do it that way. Especially since I have to do this side, flip it over, do the other side. So anyway, we did the first one, now we're on the second one. 12 inches, 4.5625, 4.5624, close enough. Let's do it. Okay, so now it's time to start welding. Since we had that little bit of a delay on the milling machine, I think I said in an earlier clip, I burn up both of those hole saws, or hole cutters rather, that I bought off Amazon. So bought a couple more. They should be arriving well, before 7 p.m. today, according to Amazon. So while we're waiting, why don't we go ahead and start making some arcs and sparks? No pun intended for you Ohio 4-Hers out there who may be watching. At least I think that's still a 4-H project. arcs and sparks, that is. At any rate, it's time to start welding on this. I'm gonna get this main piece welded on. That's gonna take some time in and of itself, because I'm probably gonna make a multiple fillet pass there around where the old hitch was, and also on the back side up and down. Really get that welded on good for obvious reasons. So that'll probably take well, I don't know if it'd take the rest of the day, but it's going to chew up most of the time that I have. So without further ado, I'm going to go fire up the old Hobart and see if we can't start welding this on there. Okay, so now put down 3 weld passes plus our tacks. You can see looks like we're getting pretty good penetration. You can see here kind of that discoloration. I don't know how well that's showing up here on the video, but we're definitely getting good penetration down here. You can kind of see it getting through into that. So not bad for the first pass there. You can see the vertical. And then over here as well. I gotta run the chipping hammer on that yet, but usually that's easier to do once you let it cool off. But there's the first couple of passes. Probably gonna weld inside there as well. Basically anywhere I can run an electrode, that's what we're gonna do. These are 6011s that I'm using on this. Something that's really good at penetrating, especially old steel like this. It's a good general purpose rod. I know some people like 7018s for this. The only downside to those really, well, it's twofold. One, you gotta keep them in an oven, and then number two, when you do run it, you have to strike the arc a certain way. Plus they really like clean steel, which honestly we're working with pretty clean surfaces here, but I have found over the years I just like 6011s. That's what I've always had good luck with, and knock on wood, so far everything is stuck together. Alright, so now that we got the welding complete, well, not complete, but you guys know what I meant, you know? Can't be too picky. Now we got that step complete. I'm gonna make some end caps for that cross member, and here's what I'm coming up with. I had this 6-inch stock laying in the scrap bin. It'll fit over the end of this bar stock that I'm using for the rear hitch just fine. Biggest thing is these corners. More than likely we'll melt those out with the welding rod. I suppose I could use the milling machine and dress it up, but yeah, whatever. That's just what we're gonna do. So I got one made. I'm gonna try to do this. Don't have my normal camera mount, but what I'm doing, I don't know if you can see that or not, I just put my speed square on there, right on the 3-inch mark, right on the end. and I'll call that good. So kind of come back out of here. It's so hot that I don't even have my normal GoPro hat on to free up hands. So anyway, I'm gonna go ahead and cut this and take you over here and show you what I've got done so far. The welding is done, so look at that. Nice, sort of nice weld bead. Still nice and hot too. And that's been sitting there a couple hours. I had to run an errand, and yeah, so we definitely got some good penetration there. That should be in good shape. When we're all said and done, probably gonna put, not probably, we will put some bracing that goes down to these cross members, maybe through that ladder somehow. It's kind of in a bad spot, but not much I can do about it. So anyway, that's where we're at. I'm gonna go cut off that other end piece, end cap, and we'll get those welded up, make this look nice, make it look like it rolled right out of Waterloo like that. Oh, wait a minute, tractors are made in Waterloo, not planters, and that was never made by John Deere anyway, so yeah, whatever. Okay, so after just a lot of choice words, there's what I'm looking for. After a lot of choice words, I got those holes punched in, and through some major miracle, they actually fit what I measured. Kind of proud of that, actually. Really the first time I've used that digital readout as intended, and it turned out great. So that should tell all of you people out there that are wondering, oh gee, I don't know if I can do it or not. You can do it. Start practicing. Start with a small project and work your way up. Anyway, again, this is not a tutorial, this is strictly entertainment. As I'm sure some of you experienced machinists out there are quite entertained. Anyway, what I'm doing now is I have these fitted up. They're not bolted on here or anything like that. These bolts are just in the holes, and it's just kind of gravity's holding it all in place. And what I'm doing is I'm making sure these are completely parallel. So at the top I got 14 7/8. At the bottom, $14 7/8. So I'm gonna go ahead and weld this piece on there. This is a little bit smaller piece of steel I picked up. These were in a drop box over at the local place where I get my steel. They're 2x3s. Couldn't remember what they were, but they'll cap off these pieces of tube quite nice, and we'll also use them for bracing over there. But I'll go ahead and weld that on there. Then we know we got all these dimensions correct, and we'll set the whole piece over there, weld it to that cross member that we made. Then we'll pick the hitch up and finally see what it all looks like when it comes together. So I will check back in with you once I get this piece all welded on. Through the magic of YouTube, voila. So now while I let this cool, I can kind of give you the thought process behind what you're seeing. You probably remember those uprights being a little bit taller than they are now. And that's because they were. Yeah, go figure. What happened here is I lopped off the top section, which was basically the same set of holes, just about, what is that, 8 inches, 6 inches or so higher than that set. And that way I could have 2 sets of height adjustment for my 3-point hitch. I went and measured the 4520 again of the 2 tractors. That one always seemed to have the higher of the 2, and by higher the 2 I mean like by 2 inches, probably because of the tires, or maybe just how whoever owned it last adjusted it. Anyway, that one's at 3 foot off the ground when it's fully raised. When these uprights in this position are welded onto that, those couplers will be about 36 to 37 inches off the ground, if I am measuring this all correctly. So I don't see why I would ever need to go much beyond that height. Now, I know what you're saying. Well, why restrict yourself? Well, quite simply, to put those 16 holes into that square tubing, I burnt through 6 of those cutters, hole cutters off Amazon. 6 of them. $60. I could have went and bought a Milwaukee one. Probably should have. I may still have one if I would have done that. It just goes to show you don't skimp on tools. I was trying to get away with it. I bought 2 of them initially. I pretty much got through one whole piece with the first cutter, and I was like, wow, these are doing pretty good for a $10 bit. And then, like I said, I burnt through that second one and not even a hole. About a hole and I think I ended up getting a hole and a quarter or a hole and a half out of it. Very inconsistent. All right, guys, so here we are sitting in August when I last had the GoPro on last night. I had just gotten this piece all welded together, and by that time it was starting to get close to dark, so figured it was best to hang it up for the night. But we got some much needed rain, 4/10, so I'll take it. I will take it. So anyway, I'm sure you guys really care, but anyway, I'm gonna go ahead and free this piece from its captor. Alright, so that's going to be what faces the back side. This is going to face the cart. So got some meat to it, that's for sure. Get that on there, get it centered up, get it welded in place. So I'm thinking, try to well, actually, surprisingly, sits on there pretty level. Okay, so after a little bit of brainstorming and a couple nights off, who am I kidding? A couple of days off because I had to go into work. But anyway, I got to brainstorming on this and how I want to resolve this problem. And what I'm going to do is I'm going to weld 2 of these 2x3s to this piece of angle iron that I have. And once I get this assembly done, this whole assembly is going to go up in here, and I'm going to weld it fast right here to the main axle, which is where the pulling forces ultimately go. So right now, if I were to have that 3-point on there and with a load on it, it would want to pull those uprights back. So what I'm trying to resolve is, yeah, we're getting a lot of that force transmitted down through those uprights, through to that cross member, and ultimately onto that tongue. That's really for downward pressure. So when the thing's lifted up, that's what that's resolving. We need something to basically take the forces pulling back and transmit them to the front. And that's what this is ultimately going to solve for us. So now that I got done with that whole word salad, let's actually look at what we're doing. So again, these 2 2x3s made of nice heavy steel, more of that 3/8 material. You can kind of see it here in this member. Once I get these welded onto that angle, I'm going to go ahead and weld 2 of these spacers in between. And then, this is where we're going to get creative. We're going to have a member like this come in at an angle that is yet to be specified. And it's going to go something like that. So I am in the process of making our angled supports for this hitch, and to do that, instead of using the bandsaw, I put an Ashland, I think that's how you pronounce it anyway, metal cutting blade. These are cold cut, meaning that the cuts themselves are cool to the touch when you're done, but definitely not the metal chips. At any rate, I've installed one of their 48 tooth cold cut blades on this SkilSaw, miter saw, whatever you want to call it. It's a worm drive, and the reason I went with this twofold: one, the maximum RPM on those blades is like 5200 RPM, I believe, and that saw turns at 4000, so we're safe there. And the other benefit here, being worm drive like that, I get a little more torque, which I need when I'm cutting that thick of steel. So without further ado and further explanation, let me find a good spot to sit you guys down on. Don't really have anything that's not going to vibrate. There we go. And let's make our first pass. Oh, if I had my safety glasses though. when I do this, I always like to wear a face shield as well. Let's see how we did, huh? Trying to do that one-handed is not the answer. But come over here, let's see what I'm fighting. But for the most part, nice clean cut. The reason that it leaves that little burr on the rear, these SkilSaws are a 10-inch, and to get a blade that is rated at the right RPM, I had to go with a 9-inch blade. Downside, it leaves a little burr at the tail end, but way nicer cuts than if I tried doing that on a bandsaw. What I'm trying to do is build two pieces just like this. And this one I made earlier, and that is what we are actually going to mount on the rear. Now, hopefully that is how we're going to weld those on there. Now, originally, the original plan was something like that. However, in our, precision machining and precision building, these are a little bit off square. That is a little bit off square. One of the two is a little bit off. My guess is that, just given the size and how it's welded on there, probably got some warping going on. But even if one of these is just a little bit out of measurement, 1/8 of an inch, way down there at the bottom, it can cause a lot of issues, especially when you get into doing angles like this. So this cap piece is good heavy steel. We'll reinforce it. This is good and heavy, obviously. We will do this method as opposed to the other. I don't think it really much matters, but I may put in some bracing here. Honestly, I think we're gonna be just fine. So I'm gonna go make the other cut, and then we'll get to welding. Alright, so that was an adventure in and of itself, getting that mounted up. Now that it's mounted up and I see how much up and down travel that's going to have, I think we don't need to worry about, well, too bad if we did, but turns out we don't need to worry about having that second set of holes. Where it is, lines up nice and neat as it should. What we did to line these up, so we used these set of 1-inch hitch pins. As you saw us earlier fighting with this. I thought I was going to need to hammer that in there, I guess not. For whatever reason, I thought it would be a good idea to try to use the bolts as alignment tools. I'm sure you guys out there were laughing at me. Almost mucked one of them up pretty good, but that's alright. Turned out to be all right. Now I just gotta get these raunched down on here before the sun goes down. This bolt seems to be wedged or something, in that it's not spinning. Alright, now come over to this side. What I'll probably do is after the first hour of operation, come back and check these, make sure we that one is loose. My goodness, man. Torque them down just a bit. And there, whew, there we go. I'm not sure what the foot-pounds is that we torqued them to, but you know, a few thousands of pounds, right? No. Anyway, there it is. That is the 3-point hitch in all its glory. So now we've taken a front mount 3-point hitch, got it on the back of our air cart. Now on the next video you're really gonna see a lot of screaming and carrying on, because well, we're gonna be freeing a lot of seized parts on those row, not row cleaners, but fertilizer openers, row units. So stay tuned for that. And then we got to strip down the row crop cultivator out there to get it to just a toolbar. So we got to do that yet, and then we got to do all the plumbing, all the air hoses and such. But I'd say this is pretty nice, and it's a little, in my opinion, it's nicer than what the stock one would have been, because once this bar's on here, we're gonna have all this room to come in and go up the ladder, fill up the cart, and we just have more room back here. The one thing kind of worries me, bothers me, whatever, is well, it's gonna come down to when this goes and lifts up the tool back here, it's gonna have a lot more leverage on the air cart, being that it's further back. The 3-point that originally went with these, it mounted right up there where those bolts are, and then it had its apparatus in there. So it was back probably to almost 3 feet closer to that axle. Will we have an issue with negative tongue weight? I don't know. Maybe. We'll cross that bridge when we get there. But for right now, this is where I'm going to leave it. On this, I believe it is August 9th, Friday night. So, catch you guys on the next one. If you like what I'm doing, comment, rate, and subscribe. It helps this channel out. It's a rather young channel, trying to get this started. So far it seems like there's been a lot of positivity out there. So anyway, keep them coming. We'll see you on the next one.